All right, I'll do a next quick clip on next expansion. You have 1 upon a plus 1 upon b all square. This is the same as 1 upon a plus 1 upon b times 1 upon a plus 1 upon b. Now you can use the same grid method. 1 upon a, 1 upon b, because you're using the first bracket here. And here you have 1 upon a, 1 upon b. So 1 upon a times 1 upon a is going to give you 1 upon a all square. 1 upon a by 1 upon b is 1a times 1 upon b. This is going to be 1 upon a times 1 upon b, because the order here doesn't matter, right? And here you're going to have 1 upon b all square. So this gonna be equivalent to now 1 upon a all square is the same as 1 square upon a square. Well, 1 square is 1. So it's gonna be 1 upon a square. So 1 upon a all square is gonna reduce to 1 upon a square, and this is gonna be 1 upon ab, 1 upon ab, 1 upon b squared. So you're going to have 1 upon a squared plus 1 upon b squared plus 1 upon ab, I should put it like this, plus 2 times 1 upon ab, because you have ab here plus, 1 upon ab plus 1 upon ab. All right? Now, let me look into this idea. 1 upon AB plus 1 upon AB. The denominator is the same, so AB, right, is common, and AB into AB, it's 1. 1 times 1 is 1, plus AB into AB, 1. 1 by 1 is 1, is 2 upon AB. In my, you could write it like this. Good, so we clarify that part. Let's look at something like root of a plus b square. This is the same as the root of a plus b times root of a plus b. Now you can use the grid method again here. Root of a, and this is a plus b, root of a, and this is plus b, right? This you express here, and the other bracket you express vertically. Now, root a multiplied by root a. What this means, I'll just put it here for now, root a square. Root a by positive b is b root a. And b by root a again here is b root a. And b by b is b squared. So in this case, we have this is equivalent to root a all squared plus b squared plus 2 times b root a. Right? Now, what is root a? The root of a can be expressed as a to the half square plus b square plus 2ba. But this is going to cancel here, right? You could see that. So this becomes a plus b square plus 2b root a. From the rule, a to the m to the n is equals to a m multiplied by n. The half, which is a to the half, is really the square root of a, times this 2. The 2 and 2 are going to cancel, and you're going to get a. So this is going to be the expansion of root a plus b all square. Let's look at a different scenario. What about root a minus root b all square? Now, this is the same as root a minus root b times root a minus root b. Again, the grid method. Root of a minus root b, root of a minus root of b. Now, we need to keep this in mind. We know that root of a is the same as a to the half, and root of a all square is really a to the half to the square, which is really equal to a to the half times 2 upon 1, which is equals to a. So root of something square is equal to that thing. Root of a square is a. So when we look at this here, we can quickly write this as a. This is going to be root of minus a root of b. This is going to be root of a b. This is going to be positive b, because root of b times root of b is b. So, are we clear with this? Root of a times root of a is a. This is explained here. Because the root of a is a to the half. So the root, square, like root a multiplied by root a, is really saying a to the half times 2. And you get a here. So that is why you can just look at this and get some, reduce it quickly. Okay. We also know root of a times root of b is the same as root of ab. So in this case here, this gonna become minus, you can leave the minus sign out, ab, you can put it out there, and this here gonna be the same as minus ab root. All right, so this whole expansion here would be equivalent to a plus b minus 2 root ab. because you have minus AB and an x minus AB. All right? So you want me to put it here? This here is equivalent to a plus b minus 2 root of AB. So this idea here, now if you remember this, a plus, no, if you remember, a minus b all square is a square plus b square minus 2ab. So in this case, you have root a minus root b all square. So a here is the square root of a, and you know that the square root of a square is a, plus square root of b is square root of b square is b, minus 2 root of a, this root a, root b, which is the same as a plus b minus 2 root a b. Now you'll start to see ways how you can take this here. If you just remember this a now is root a, the b now is root b, and you can apply, look at this here, and you can quickly work this mental. All right, now I'll look at one more scenario. Root of a plus root of b times root of a minus root of b. What is this equal to? So we go with the grid method. Root of a plus root of b, root of a, this is plus root of b, this is minus root of b. This here is a, this is root ab, this is negative by positive, so negative root ab. This is negative by positive is negative, but b, root of b by root of b is b. So the answer here would be a minus b. This is positive ab and this is negative ab, gonna cancel, so it's equal to a minus b. So this is a minus b. So you can go from here to here, or you can write this as the same as this. All right, so I think in some trigonometrical proofs you can apply these ideas. I'm just juggling it here so that you have a better grip on how you deal with indices, and these are fundamental concepts. When you pass this level, you can move quickly, but you need to get this correct. All right, so I will stop here.